Great to see everyone today. This is Serverless and Serverless DevOps scaling together, and we'll find out why it's called that here in just a minute. And two subjects that I'm very passionate about myself, which is the serverless stack and DevOps as it relates to serverless. Two subjects that are hot and trending right now. So we're going to talk about a little bit about both, but mostly focused on DevOps today. So I want to do a quick DevOps introduction and some best practices that I've come up with, and would love to corroborate those with anyone here if you have any input. And then talk about how serverless DevOps differs from traditional DevOps. And I think there's discussion warranted for serverless DevOps and a lot of differences in how the model is changing as it relates to traditional DevOps. And then some of the benefits, common blind spots, best practices, and why serverless and DevOps fit so well together. And then, probably what you might be here for is a plan that you can actually put in action to scale your serverless DevOps strategy. And just really quick, this is my face on the screen, as you can see on the camera. I'm going to go camera off here in just 1 second for the recording. But I am Aaron Lieberman, as Stephanie said. I'm the Cloud Practice Manager here at Big Compass. I'm AWS certified developer and certified solution architect. And I'm also certified with MuleSoft and a couple other technologies. And I actually started with the integration related iPaaS technologies like web methods and like MuleSoft. And I sort of graduated to focusing more on AWS over the last 5 years and got my AWS certifications and a true believer, true proponent, true, I guess, evangelist even of the serverless stack, specifically on AWS. And I believe that you can do a lot with the serverless stack, and there's a slew of benefits, especially as it relates to integrations. And, I've helped customers move from MuleSoft to AWS serverless, for example, or even combine, the technologies like MuleSoft with AWS. So, if anyone wants to reach out to me on LinkedIn, please feel free to do so. That's Aaron Lieberman. You can search for me, and I would be happy to connect and talk more about integrations and how they relate to the technologies that we're talking about today. Big Compass is a consulting company, and we specialize in integrations and related technologies. Those are the technologies like Delboomi and MuleSoft and AWS. And I myself am specifically in charge of AWS, and we do some practicing with Confluent as well. And we're AWS partners. As you can see on the screen, we have a service delivery specialty with AWS Lambda, API Gateway, and DynamoDB with AWS. And we love our partnership with AWS. I truly believe in that technology, specifically, the serverless stack. And we focus on building connections here at Big Compass. We build connections between systems and applications. That's the integration side of things, of course. And almost more importantly, we build connections between people and ideas. And especially, right now, when everyone's working from home, remote, distributed, it's even more important to build those connections between people. And that's exactly what we're trying to do here today. So nice to see everyone. Thank you for joining. I'm going video off here so you don't have to look at my face. And let's talk about DevOps. That's what we're here to talk about today. So really, DevOps is a culture and a mindset. And I've heard many people say this, and I've read many blogs that have said DevOps is a culture and a mindset, but what does that actually mean? So Agile is actually the umbrella overarching over DevOps, right? Agile is the overarching framework that encompasses everything from business needs and stakeholder engagement to delivery. And when you adopt the Agile framework, you're probably familiar with the Agile framework by this point. It's pretty common. But when you adopt the Agile framework, you're moving from a traditional, maybe waterfall model where you're delivering very large projects in very large chunks. And the Agile model, I like to think of it as pretty much the opposite. You're delivering iterative success. It's small chunks and small success quickly, rather than the large chunks of projects a little bit more slowly. And then when you take on a culture and a mindset of adopting DevOps, now you're part of that Agile framework. And DevOps is closer to a set of principles and processes for streamlining, the building of your software and your testing and your releases. And DevOps when you adopt that culture and that mindset, you're trying to focus on speed and efficiency, those small chunks, those small iterative wins over time, and develop many features very quickly. And then just to differentiate between DevOps and CI/CD, I see this mistake out there a lot, that people think that DevOps and CI/CD is actually the same thing. Well, CI/CD actually fits under the umbrella now of DevOps. And CI/CD is a process used within DevOps, actually. It leverages tools, like Jenkins or like AWS Code Pipeline as part of your implementation of a DevOps process, and can facilitate and simplify DevOps through automating parts of service delivery. And so CI/CD is focused on a single automation, usually around, building and deployments, right? But it's only one process actually of your DevOps umbrella. And so, like I said, DevOps focuses on speed and efficiency, and that's how you can really measure your success, based on KPIs that you can define when you adopt a DevOps culture and a mindset. So hopefully that helps you understand the culture and the mindset around Agile and DevOps, and differentiate DevOps and CI/CD for you. And so let's talk about some of the DevOps best practices. And again, you might have seen these before, and I'm going to compare and contrast these with serverless DevOps here in just a minute. And so the first best practice that I like to throw out there is define your process before implementing. It's almost like a duh best practice. But when you really think about it, a DevOps implementation is just like any other project. You want to go through a design phase and define your processes before you actually get into implementation. I've seen a lot of DevOps implementations go wrong because they weren't designed and processes weren't defined before actually implementing. So you'll go through your design process before actually implementing. And then document. Can't stress that one enough. Come up with playbooks and checklists and templates that you can go through, so that your DevOps solutions can be documented, repeatable in the future, enforced, can be read by developers, can be easily adopted by developers and across the business. And you might even think about creating standards for your great DevOps processes to scale out across your business. And using source control, again, almost a duh best practice. I think most people use source control these days, whether it's GitHub or Bitbucket or GitLab, what have you, AWS Code Commit, use source control. It's so important to be able to check in your code to a distributed source control and have all of your developers collaborate using one mechanism. And automate processes. So DevOps focuses on speed and efficiency. I said that on the last slide. And the automation of your processes is really what helps you increase your speed and efficiency. So you can think about automating deployments. You can think about automating QA processes. You can think about automating security even. You can do dependency checks, for example, and make sure that your dependencies are actually up to par for your security needs. You can even do some automation of code quality checks. There's tools out there, some really great tools actually, that allow you to define some standards, and in your builds actually allow you to check the code quality and help you enforce some code quality standards. You might do manual approvals for production also. So CI/CD is absolutely amazing, and I love it for lower environments, but I typically recommend, unless there's a one-off unique scenario where you want to be able to deploy to production at any time of any day, you do manual approvals for production. And this is so common now with mature organizations where you have, a change advisory board, for example, and your change advisory board allows you a window, let's just say every other week on Wednesday mornings, to deploy to production. Now with manual approvals, you can go in, you can ensure that, maybe 1 or 2 or 3 people have the ability to actually approve your production deployments, number one. But then number two, you can also control at what time those production deployments are actually taking effect. And then use infrastructure as code. So I can't stress this one enough. And infrastructure as code in a traditional DevOps model might not always it might not always be feasible in a traditional DevOps model. Let's say you're deploying to a legacy system within a data center. You might not be able to necessarily use infrastructure as code, because infrastructure as code is usually used to deploy to AWS, to Azure, to Google Cloud, and so on and so forth. But if you adopt this cloud model now, you can start to use infrastructure as code, and we'll talk about that more later in the presentation. And review measures and goals. Treat DevOps like any other project. That's just like the first and second best practice here. Treat it like any other project and measure your KPIs and measure success and communicate completion. So now here, what I'm really excited to talk about is serverless DevOps, right? And how does DevOps differ from serverless DevOps? And first of all, I want to answer the question, why are we even talking about serverless DevOps in the first place? What does serverless DevOps even mean? Well, let me set the stage with serverless in the first place. Serverless is undoubtedly the hottest technology trending in the marketplace right now. It's the fastest growing service for both AWS and Azure. And there's truly an alarming adoption rate across industries, as you can see from this image on the right-hand side. There's industries adopting serverless at over a 200% clip. That's crazy. And the average for these top industries adopting serverless is over 50%. It's over 60% even. And so with the rise of serverless, we need to be prepared to handle a growing serverless footprint, where the focus in serverless is on building many concise distributed microservices that scale rather than large monolithic systems as we've seen in the past. And I really love serverless. The slew of benefits of serverless make it such an attractive offering. It's a double-edged sword though. And so, serverless allows you low cost and great flexibility and scalability. But on the other side of that same coin, you now have a large serverless footprint to manage. You have many different serverless services to manage. And you have many microservices making up a single application or system. And now what that means is you can start to mitigate this risk, I'll call it, with serverless by really putting a focus on governance. And how do you manage this? How do you implement great governance over serverless technology in the expanding footprint? Because it's so easy to create such a large serverless footprint. Well, prepare to adopt serverless properly with serverless DevOps. And that's exactly what we're here to talk about today. So this is sort of the staging slide before we talk about serverless DevOps. And so DevOps versus serverless DevOps. What is DevOps focused on? Well, I already said it earlier in the presentation. It's focused on speed and efficiency, right? It has a mission to streamline deployments to a single application. And so let me define serverless DevOps really quick and explain why there's a necessary distinction between traditional DevOps and serverless DevOps. I just talked about serverless footprints, and with a traditional monolithic application, let's just call it an application that you would deploy to AWS EC2. What you would do is you'd probably have that entire code repository, in a single, let's just say GitHub repository. And any changes that you make would be checked into that GitHub repository, and you would make a single deployment using a single CI/CD pipeline out to your EC2 instances. It's nice, straightforward, smooth, streamlined, very easy to implement, and everyone likes that. But now in the new serverless model, to make up that one application, you're probably going to be breaking that up into 5, 10, 15, maybe 20 plus different serverless components to just be able to make up that single application. And so serverless DevOps needs now a bit of different focuses. It still has a focus on speed and efficiency, and the mission is still to streamline deployments to numerous serverless microservices. But now you have an additional focus in serverless DevOps on governance, because governance is so key to managing your expanding serverless footprint. And you have an additional focus on scaling your serverless footprint. And I'll talk about that more later in the presentation. And your DevOps best practices and benefits are only amplified with serverless DevOps. And by that, I mean, you can take the same DevOps best practices and really put even more focus into them in the serverless world. So let's compare and contrast that just a little bit further and drive that home. Because a typical DevOps process might look like this. And this would be an application potentially deployed to AWS EC2. And how you might accomplish that in the traditional DevOps model is AWS code pipeline would be watching a GitHub repository. And then code build would allow you to build your code when you check in changes to a specified branch. You could have your manual approval step in there. And then Elastic Beanstalk on AWS is absolutely amazing. Makes deployments to EC2 very, very easy and simple, just with some simple configuration. You could deploy a load balanced application onto multiple EC2 instances pretty easily with this model. It's nice, straightforward, simple. We all like this. And let's compare that now with the serverless DevOps typical process. And you can see right away, you know, on the right-hand side here, we're seeing a lot of things change. It's not a monolithic application anymore. But on the left-hand side, you see that actually your process is fairly similar. You start off with AWS code pipeline, looking at GitHub, and then AWS code build, building your code. And you have a manual approval step. And now your actual deployment step might change. You might use SAM, for example, for serverless. You might use the serverless framework. You might use CloudFormation. Right? There's a bunch of different options out there. I like to put in CloudFormation here in this diagram. And whatever you use now, you're going to be using that infrastructure as code tool to be able to deploy numerous different serverless services to make up your single application. So this would be an example of just one pipeline now, and you have 8 serverless services making up that same application that we saw from the previous slide. And so you have to be able to manage that and govern that and scale with that process. And you can see how the mindset changes also. So one more slide just to really drive this point home, where serverless DevOps I took from the Big Compass AWS instance. We have quite a few pipelines stood up for serverless, and we have some for traditional DevOps as well, because sometimes that traditional monolithic application is necessary to deploy to EC2. For our CloudFormation stack, deploying a serverless, so a bunch of serverless services that make up one application, we have 1,120 events in that particular deployment for our serverless services. You can see that traditional DevOps has 46 events. It is a stark contrast and stark difference between serverless DevOps and traditional DevOps. And it's because serverless DevOps is going through, you can see some of these events on the left-hand side. It's creating so many different assets when you're using serverless. It's creating the IAM policies, it's creating the Lambdas and SQS and SNS and API gateway and so on and so forth. Whereas traditional DevOps really only has to do a few things. It has to do a build of the code and deploy off to your EC2 instances, following that example. And serverless DevOps benefits. So I talked about those benefits in one of the previous slides. And DevOps benefits are rapid innovation. It allows you to innovate quicker because you can accelerate your deployments. You can eliminate some mistakes. You can go through automations, right, and provide a great developer experience that allows developers to focus on what they're good at, and that's development. You don't want developers necessarily going into the QA phase and having to test in QA and conducting UAT and conducting regression testing, and then building checklists to then go and deploy what they've developed. Developers just want to develop, so let them do what they're good at and what they want to do, and leave the testing and deployment pieces off to automations and CI/CD under your DevOps umbrella. And you can also achieve enhanced security with DevOps. And you can do dependency checks. You can do API security checks even as part of your DevOps processes. And now with serverless DevOps benefits, all of those benefits I just listed still apply, and they're only amplified with serverless if you really think about it. And serverless DevOps benefits now have some additional benefits that we can talk about. Number one is governance. When you implement great serverless DevOps, right along with it, you're almost forced to put a focus on governance. If you create the great processes and you're creating infrastructure as code, and you have a great inventory of your serverless footprint, well, now your governance comes right along with that. You're almost getting into a self-documenting nature if you're doing serverless DevOps the right way. And we'll look at how to do that here in just a little bit. But you're taking a self-documenting approach to gather that inventory of your serverless footprint. And that inventory of your serverless footprint is such a crucial, I think, underrated aspect of serverless, because your serverless footprint can grow to thousands of AWS Lambdas, hundreds of queues, hundreds of topics, thousands of topics even, many different database tables, so many different S3 buckets, right? And you need a great inventory of those to be able to just basically keep them reined in and have an understanding of what your system does. And then you want to templatize serverless microservices also. And you can do this in a couple of ways. So if you implement serverless DevOps processes the right way, I think it should be largely in collaboration with developers. Developers are really your end user using your DevOps processes. They're going to be the ones actually going through the service development lifecycle. And if you can templatize with them, let's say a Lambda folder structure where they can scaffold out where unit tests go, where code goes, where build files go, that's going to help them right off the bat in creating their Lambda footprint. If you can also create with them, maybe instances of Lambda layers even, and Lambda layers give you the ability to reuse certain functions. Maybe you create a Lambda layer for your error handling that's reused across all of your Lambdas, and you build that into your CI/CD pipeline that for any Lambda that you deploy, you add in your Lambda layer for error handling. Now you don't have to ever worry about error handling again because you've built out a framework for it. You could do the same maybe for logging even. Build out a Lambda layer for logging and then include that now in your DevOps processes. And that's what I mean by templatizing serverless microservices. So just some food for thought there. Some common blind spots, really the antithesis of some of the best practices that I've listed. Serverless DevOps is the same as traditional DevOps. That would be false, at least in my opinion. And that's the point that I'm trying to make in this presentation, is that traditional DevOps is focused on deploying monolithic applications and processes around monolithic applications, whereas serverless DevOps is focused on many different microservices and new processes around those many different serverless microservices. Not designing before implementing. We talked about that one. You want to be able to design before you implement and work with developers and work with your stakeholders before you actually go into creating your assets. And no plan to scale your DevOps processes. I'll talk about this one a little bit later in the presentation, but you need a plan to be able to scale your DevOps processes. And what I would recommend is you plan to scale your DevOps processes with your serverless footprint 100 times more than what you think you will scale to. In the serverless world, it's just so easy to expand your footprint that anything under 100x of what you think, I think is short-sighted. Lack of communication. I don't know if anyone here has ever seen DevOps, engineers come in and implement great DevOps processes even, but then they're not evangelized and they're not communicated to developers, they're not enforced, and developers don't know how to actually adhere to those DevOps processes. Well, I think that's due to a lack of communication. So you still need to evangelize and communicate what your DevOps processes are doing, the benefits of them, and how developers can use them. And serverless implementations can be successful without serverless DevOps. And this is, I would say, the secondary point that I'm trying to make in this presentation. Number one would be serverless DevOps is different than traditional DevOps. Number two is serverless implementations cannot be successful without serverless DevOps. And in the serverless world, I've said this over and over, your serverless footprint can expand so rapidly. And if you don't take the time to implement serverless DevOps right along with serverless, again, it's going to be short-sighted and you're going to build up technical debt that will hurt you in the future. And you're not going to have a good measure on what your system does, the components of your system. It's going to be very hard to keep that inventory of your system. And then forgetting to measure success. So I've seen lots of great DevOps processes implemented, over the years, and measuring success actually doesn't happen very often. And we'll talk about measuring success in the final plan here in just a minute. And serverless DevOps best practices, if you look at this slide, you might think that it looks very familiar, and that's because it's the exact same best practices as what I just went through for DevOps best practices. And I told you, a couple slides ago that your serverless DevOps best practices only are the best practices from DevOps, but they're amplified best practices from DevOps. So for example, let's go through these. Defining your processes before implementing. So now you define your processes to scale in the serverless world. Document the solution. So maybe now you still document playbooks and checklists and templates, but maybe now you also document onboarding with your serverless services. I have been the recipient of creating many different serverless services, primarily with AWS Lambda, and an onboarding document as to, you know, what the folder structure will be, what are the coding standards, and so on and so forth for your serverless services, specifically with Lambda, would have been very helpful in the past. Source control. So now I would advise you to use a different repository per application or connector or component of your system, and that allows you to define more granular DevOps processes. And that's a change that you might see in source control, is that you're breaking up into more repositories to scale with your serverless footprint. And automating processes. So now, you know, you still automate your deployments and so on and so forth, but you might also automate the onboarding for new serverless components or connectors or applications. And again, you know, I mentioned previously, you might automate the onboarding of doing that by templatizing your Lambda folder structure or creating Lambda layers for your reusable components. It would be a great efficiency gain to do that. Manual approvals for production. So you might have more approvals now based on how you split up your deployments, and there's options to split up your deployments. And infrastructure as code. So now in the serverless world, infrastructure as code is almost a must. I would highly, highly recommend infrastructure as code and to take the deep dive into infrastructure as code, because I can't stress enough how important it is. So you can use SAM for serverless. You can use CloudFormation. You can use Terraform. You can use serverless framework. There's plenty of tools out there, but whatever you use, I really can't recommend using infrastructure as code enough. You know, it's self-documenting. There's so many different benefits to using infrastructure as code. And then review measures and goals. So again, you know, treat DevOps like any project, and your measures and goals now would probably change in the serverless world to look more based on measuring success based on how many features you've developed and how quickly you've developed those features and how many deployments you've made over time and how quickly you squash bugs and things like that. And so now the perfect harmony between serverless and serverless DevOps is what we're going to talk about. So in serverless environments, for just one small application, you know, you might see 5, 10, 15, 20 different, you know, plus different serverless components in there. And what I have on the screen at the bottom on the right-hand side are just two examples of that, where you would create, you know, an API gateway and Lambda and S3 and DynamoDB and AWS SQS and AWS SNS and so on and so forth. And you really have to split those up and be able to manage those, again, in your infrastructure as code. So serverless environments are scalable and flexible and cost-effective. And again, governance is key. And you manage that growing serverless footprint with serverless DevOps, right? And now we see the same diagram as we saw before. Now the serverless DevOps model needs to scale with your serverless footprint. And you design it for easy onboarding. And what I mean by that is you're going to be creating a bunch of, if you're using AWS, a bunch of AWS Lambdas to be able to develop your applications. And you want to be able to onboard and sort of templatize those AWS Lambdas, because we're going to just be creating a lot of them. And so you can get some great efficiency gains by templatizing those. So you want to enable many features and deployments to be created. So serverless and serverless DevOps, it really is the perfect harmony. I believe they are a package deal. I believe that serverless implementations can be successful. Serverless implementations can fail also, even though it's such a great technology. It's not the technology that would lead you to failing, though. It would be the implementation, the processes that you develop around that technology that would make you successful, right? So you can be successful if you implement serverless with DevOps, and that is the long-term strategy to success. And without DevOps, serverless just becomes very difficult to govern and scale. You know, today, maybe you only have 5 serverless services. You know, tomorrow it's 10, but then next year it's 100 or even 1,000. And you get into a world where, you know, you just have so many serverless services floating around and you need to be able to rein those in. And so DevOps was always a huge benefit in traditional models, but it becomes a necessity now in the serverless model. And so, you know, again, the point that I'm trying to make is serverless combined with serverless DevOps is the combination needed for success. If you're undergoing a serverless project or considering serverless, I would just go ahead and bake in DevOps into that project. You know, they're a package deal. So maybe what you've been waiting for, maybe why you've attended, serverless DevOps strategies. So let's actually look at some hard-hitting strategies from our experience, and you can reach out to me for a custom plan, but this is what a high-level plan might look like to actually implement your serverless DevOps strategies. And I've seen this in action. Big Compass folks have seen this in action, and we know what will go wrong with serverless implementations, serverless DevOps implementations, so we can help plan for that, and we can help plan for DevOps future success and scale, right? And here's some steps. These would be 7 kind of typical high-level steps that you can take. So I put 0, 0 as even before step 1. I mentioned this previously. I would plan to scale at least 100 times beyond your goals or current state. And that might mean, if you think that your current design is going to take 10 different serverless services on AWS, I would plan to scale up to 1,000. And that's going to force you to design your processes such that you're not going to reach bottlenecks when you do get up to the many thousands or tens of thousands even of your serverless services that are floating around in AWS. It's going to help you rein those in right from the get-go and create great DevOps processes to be able to scale with your expanding serverless footprint. And then step 1, you would define and document processes that developers can easily adhere to and that DevOps can enforce. And I think the enforcement it's not necessarily a requirement, but it's great to enforce upon developers, because if you've ever implemented DevOps processes, you might hear some mumbling and grumbling from developers, right? And that would go to step 2. You want to be able to evangelize and enforce the DevOps processes across the business. Now, developers might have a little bit of pushback, but I think in step 1 and step 2, if you're working with developers right from the start and you're getting collaboration from them, you're getting input from them, and you're getting input from your stakeholders, then you're probably going to mitigate the risk of developers pushing back on you once you actually enforce those DevOps processes. And if you evangelize your DevOps processes, then guess what? You can explain the benefits of your DevOps processes to developers. Go and explain the benefit to a developer where that developer no longer has to worry about testing and deployments, and watch that developer's eyes light up, right? I don't think any developer is ever going to complain about not having to worry about testing and not having to worry about deployments anymore. So you can explain those benefits to your end user. Step 3 would be measure and document current state KPIs. Again, an often missed step. Measure your baseline. Measure how quickly you're developing features and how quickly you're deploying today, and maybe even measure how many bugs you have in production, how quickly you're able to squash those bugs in production as well. So measure your current state APIs. These will be different for everyone, but they'll probably be make sure that you can carry these same KPIs over to step 5, which we'll get to in just a second, which should focus on speed and efficiency. And then you go into your implementation phase. Step 4, you implement your processes and automations and security checks and so on and so forth. And step 5 would be after you implement, probably after some time, you need to go through some features and deployments, but you measure and document KPIs in your new serverless DevOps environment. And hopefully now your KPIs have only gotten better, and you would communicate those new KPIs to stakeholders, and you would communicate the benefits of your implementation. And then 6, you would refine processes and implementations. So, it's just like any other project. You're probably not going to absolutely nail it 100%, rather than forget it the first time. You're probably going to get, maybe 90% of the way there. And then you're going to want to make tweaks and improvements over time, or even identify a phase 1, phase 2, phase 3 type of approach. And then, you probably repeat some of these steps, right? Remeasure your KPIs, go back to your documentation, evangelize any of the tweaks that you're making, and so on and so forth. And so in practice, I've talked to AWS solutions architects about this. I've brainstormed amongst the cloud practice here at Big Compass. I've picked some, smart minds that I know in the industry to come up with these options. This actually took, it's a fairly simple slide, but it took quite a bit of research and discussion actually to come up with this slide. And if you think about it, I've mentioned many times, scale your serverless DevOps processes, right? And so easier said than done. You might have thought that even, Aaron, you can preach that, but how is that actually implemented? And I think there's 3 options to scale your serverless DevOps processes. And number 1 would be to add to your infrastructure as code. And in this model, you would continue to add to your infrastructure as code configuration files for each new serverless service that you create. And so in this model, let's just say you're using CloudFormation, and in your CloudFormation stack, if you develop a new Lambda or create a new SQSQ or a new SNS topic on AWS, you would simply add it to that same infrastructure as code file, your CloudFormation stack. And over time, that CloudFormation stack would just grow. It would grow over time. And that's one of the downfalls of this approach. But maybe for a smaller serverless implementation, maintaining a single infrastructure as code file and a single deployment and single code pipeline could be the approach for you. All 3 of these approaches could work in different scenarios. So it's really good for managing your entire serverless footprint in one place. You have your single infrastructure as code file. You would have a single code pipeline making all of your deployments, a single build, and you would essentially deploy from one place. But it needs improvement for deploying single services and updates to your microservices. So, the downfall of keeping all of that managed in one place is it's hard to customize the different components and deploy in different ways. And you also have a potentially very large infrastructure as code file. So option 2 would be replication. So you could then basically take the exact opposite approach. Whenever you want to onboard a serverless component, you could replicate CI/CD pipelines, replicate your infrastructure as code file, and any other CI/CD components and DevOps processes that you might have for each new deployment. And that's really good for customizing deployments for each service and application. So that this option could be good for, let's say you need a very custom, unique deployment for each component of your system, because it's just that different. Each component of your system is that different. It would be a good model for that. And it needs improvement, though, in managing the number of services to keep track of. So if you went with this model and you tried to scale this out to a large serverless footprint, you'd probably run into trouble fairly quickly, because you're going to have a bunch of CI/CD pipelines out there, an AWS code pipeline, and have a bunch of infrastructure as code files, a bunch of code repositories, and a bunch of deployments and processes to manage. And so to really be able to scale this out, I don't think option 2 is the best option. Again, it can work for potentially a small serverless footprint. And now the hybrid option, I believe this would be the best option in almost every scenario. The hybrid option would be a combination of the first 2 options. So you combine the first 2 approaches to logically replicate CI/CD components when necessary. And so let's take an example. If you have a system that you can sort of break out into, let's just say 5 different components of that system, you could then break out each one of those 5 components into a separate CI/CD pipeline, separate infrastructure as code file, and separate repositories, so that you can customize each one of those components of the system. You can deploy each one of those components of the system independently and not worry about one component of the system affecting another component of the system. And you reduce your management and overhead by still coupling certain components of the system, also I'll call them subcomponents of the system together, but you're logically separating out the major components of your system. So it's sort of the best of both worlds. You can still customize, and you're logically grouping the subcomponents of your system. And now it needs improvement, though, as the serverless environment expands. And again, as your serverless environment expands to thousands and thousands of serverless services, you still need to be able to think about how you're going to group those components together. And so I think with the right grouping, the right planning, you can actually mitigate this risk. And you can do that with great documentation, great inventories, and coming up with some of those rules of engagement as to how you will separate out your serverless services into like components to couple in your deployments. And this is the last slide that I have. So what would be your next steps? You can take the plan that I just covered and proceed with your DevOps teams and enable discussion about scaling your serverless footprint, or implementing your serverless. Maybe it's a serverless POC if you're just looking at implementing serverless. You can take a serverless footprint that you currently have and sort of inventory the components of your system and logically break them up. And I would encourage you to do so. Feel free also to reach out to me as a part of the Big Compass team, and we can come up with serverless DevOps plan, and I can give you either sort of my out of the box serverless DevOps plan, which is a PDF that I can hand over to you that would work for most people, or we can even come up with custom plan based on talking about your unique scenarios. And ultimately, I just want to give you a blueprint for success. This presentation will be available afterwards, publicly, and you can download this presentation and watch the recording of this presentation and go about implementing serverless DevOps yourself. But feel free, like I said, to connect with me, and I would love to take any questions at this time. Before I actually do, in the appendix here, if you are going to go hunt down this presentation, you can dive a little bit deeper too, and there's some links here to do that. So there's some great readings out there that you can do on serverless DevOps, and there's a few supporting videos as well that we have out there. I didn't actually have time to go through a demo today, but we have some demos out there that are publicly available on serverless DevOps and the benefits and how you might go above and beyond with QA automation and account creation and a couple other things. We'll have more supporting videos coming out on those soon. So feel free to download this and go to those links, or our YouTube channel, and all of those assets are out there.
Awesome. Again, we're just going to close it out then. We are always available. You can reach out to me or Aaron via LinkedIn or email. Thank you so much for joining us today at our webinar, and we hope you have a wonderful rest of your day.